Okay, in this lesson I'm going to use a contingency table to establish what's called the multiplication law. Okay, and the multiplication law just comes directly from the law, the conditional probability law. So if we look back at the conditional probability law, the conditional probability law said the probability of B given A was equal to the probability of A intersection B divided by the probability of, what's the condition? A. So given that event A has occurred, what's the probability of event B occurring? That's what that means. And this is one of my kind of classic triangular little multiplication relationships. We have the probability of A intersection B divided by the probability of A, and that's equal to the probability of B given A. My multiplication rule just makes the intersection the subject of this formula. So my multiplication rule says the probability of A and B occurring is equal to the probability of A occurring multiplied by the probability of B occurring given that A has already occurred. That is my multiplication law for probability. Okay, so remember also every time you see intersection that can be replaced with the word and. So the probability of A intersection B means the same thing as the probability of A and B. The probability of A and B occurring is equal to the probability of A times the probability of B occurring given that A has already occurred. And you need to learn that by heart. Okay, so we've got three laws established at this stage: the addition law, the conditional probability law, and the multiplication law. You got to know them all, and they can all be kind of shown using contingency tables. Let me look at one example. So two cards are drawn at random from a standard deck of cards. What is the probability that they are both jacks? What is the probability that one is a jack and one is a queen? Okay, so two cards are drawn at random from a standard deck of cards. What is the probability that they are both jacks? So let me just define two events here. I'm going to call event F is the outcome that the first card is a jack. And I'm going to call S the event that the second card is a jack. Okay, so remember we're dealing with a standard deck. I've also just drawn up here what's in a standard deck. You know, there's 4 suits: hearts, diamonds, spades, and clubs. Each suit contains 13 cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. There are 52 cards altogether in a standard deck. So the first question here says, what is the probability that they are both jacks? So we're saying, what is the probability of F and S? So again, what does F represent? The first card is a jack. S represents the second card is a jack. What's the probability the first card is a jack and the second card is a jack? And again, if I think about my multiplication rule, that's the probability that the first card is a jack multiplied by the probability that the second card is a jack, given that the first card is a jack. So the probability that the first card is a jack, what's the probability that the first card is a jack? Well, how many jacks are there in a standard deck? Well, there's a jack of hearts, a jack of diamonds, a jack of spades, and a jack of clubs. There are 4 jacks in a deck. There are 52 cards altogether in the deck. So the probability the first card is jack, that's 4 out of 52. So that's the probability that the first card is a jack. So what about the second probability? The probability that the second card is a jack, given that the first card was a jack. Well, what happens, given that the first card is a jack, what that does is, well, once I've removed the first card, that's reduced the number of cards from which I'm choosing from 52 down to 51. I'm no longer choosing from 52. Also, given that the first card was a jack, means I no longer have 4 jacks from which to choose. I now only have 3. So what we have here is 4 over 52 times 3 over 51. And I think that works out as 1 over 221 when you do that multiplication. So let's look at the second one. What is the probability that one is a jack and one is a queen? This is a little bit more complicated, really, because there's 2 different approaches I can take here. I can have the first one being a jack and the second one being a queen, or I can have the first one being a queen and the second one being a jack. So let me write this down as the probability of a jack and then a queen, or a queen and then a jack. So what's the probability of a jack and then a queen? Well, it's the probability that the first is a jack, which is 4 out of 52, times the probability that the second is a queen, given that the first was a jack. So if the first was a jack, there's only 51 cards left in there, but there are still 4 queens from which to choose. Or, if we know my addition rule, we'll say that's a plus. The probability that the first is a queen, and then the second is a jack. So, there's a 4 in 52 chance that the first is a queen. Times, well, if the first is a queen, there's only going to be 51 cards for which to choose, but 4 of them will still be jacks. The addition rule would say subtract then the probability of both of these happening. Well, both of these can't happen. Either it'll be one or the other. Jack and then queen, or queen and then jack. So the probability of them both occurring is 0. So I don't have to worry about that. And then that all just goes into my calculator. So 4 over 52 times 4 over 51. Plus 4 over 52 times 4 over 51. In other words, we're just doubling the 4 over 52 times 4 over 51. And I'm getting 8 over 663. And I've just used a calculator there. I haven't done any calculations. I've just literally typed that into my calculator. Okay, so that is the multiplication rule for probability. The probability of A and B is equal to the probability of A multiplied by the probability of B given A. And you've got to learn that off. Make sure you can follow it. Okay?